Yeah.
Yeah. So this is basically the course schedule. And what's on this is a list of everything that we are going to be covering. And I'll try and get as much information as I can in about the test and the final and answering your questions as we go along. So quick summary. Chapter 14 was basically an introduction to partial derivative, right? And how to find maximum and minimum values of multivariate functions. Chapter 15 is how to do double integrals and how to use them. This second part was triple integrals and how to use them. Then we go into chapter 16, our last chapter, and it's to do with vector functions, vector fields. And we looked at line integrals, and then we spent at least forever and a day finding different ways to get what's called the flux, F-L-U-X. And that's kind of the big picture. Our exam will be on Friday from 10 till 1. If any of you can't make that time slot, will you, nobody's contacted me from this class yet, but will you contact me and say, look, it interferes with my biology exam, in which case I'll move you to a different time slot. Your exam should only take you approximately 2 hours, but it's scheduled for 3, so there won't be any real hassle with time. But everybody should, in that time, you should be able to do what you know what to do. I'm not giving you 12 hours where you could basically look up every question on the textbook, spend half an hour figuring out how you do it, and then come back and do question 1, right? That's not a final anymore. So it's not an unlimited amount of time, but if you know what you're doing, 2 hours will do it. If you need a little bit of time extra, you've got a third hour, and that's what it's for. Any questions about what the content is, or do you feel comfortable you know what the content is? Right. Let's talk then about what your test is going to be like. I've already spoken quite a bit about it, but not everyone was here or maybe paying attention yet. Our test is on those 4 sections. It's the last test is optional. If you've got 4 good tests and you know you're not going to improve on it, then you don't need to turn up. You will be given attendance. If you want to turn up just so you can use it as a practice, feel free to do so. If you just turn up and don't like it, you can leave. It won't matter to your grades. It's the best 4 will count. It's going to be like every other test, which means it'll be a Zoom meeting and I'll get to see you to make sure you're not using your big brother or sister. And when you're finished, you upload it into Canvas. Your final exam will just be a big version of that same thing. So it'll be a 3-hour Zoom meeting, at the end of which you'll get about half an hour to get it uploaded into Canvas. When you do your final and your test, but definitely when you do your final, will you please make sure that you do working for everything and that you upload that working into Canvas using the usual scan it using Adobe Scan or whatever method you've got. If during the test or the final some technical disaster happens or whatever, you can still send me to my email address, drobertson@olympic.edu, your working. You can do it as a PDF or whatever means if Adobe Scan suddenly crashes on you. Right. Are we good about the content in the final? Is there any questions about the final that you want me to talk to explain or talk to you about? We all cool, we all know when it is, we all know how it's going to happen. Okay.
I assume there's going to be no class Tuesday, right?
Correct. I see you Monday. For those who turn up for the test, I see you at least. And then I won't see you again until Friday. Now, I'll be doing other classes' finals during that time. So if you need a Zoom meeting or something, we may have to arrange a schedule. You know, I can't see you at this time slot, but I can see you at this other time slot, and we can, you know, because you might not know what you don't know until you've, you know, done the last homework, or you start revising for the final and you say, how in earth do you do these Lagrange multipliers, right? My notes make no sense to me. I need help here, right? Whatever it might be. Then you might want to talk to me, and we could do a quick Zoom and fix it. But yeah, your short answer, which I don't always give, is I won't see you any other day except Monday and Friday of next week. Any other questions about the final or the test? Yes?
Sorry, I'm still a bit confused about what the schedule looks like. So Monday, we have test 5, and then what about the days before Friday?
Nothing happens. I won't see you. You're just going to use that time, whatever you're doing, hopefully revising for finals, mine included.
Okay.
And I won't see you until Friday.
Okay.
Gotcha. Right. I was about to say, you know, your final is mega big. 30% of your grade is on that one cumulative final. So you want to be prepared for it. You want to do your best. That's why I keep saying, show me you're working. You know, if you forget, if you do +2 and it should have been -2, WebAssign will give you a big fat 0 because it's not clever. And that's why I need your working, so I can see where you got the answers and what you did. If it's a simple mistake like a missing sign, you'll hardly lose much more than a point or two. Even if you can only do half of the question, you know you're going to get half the points. So working is important. So I can't emphasize that enough. Let me back out of this page and show you something that's new. I'm assuming you can see Math 264 formula sheet. Do you see that on your screen? A nod, right? I got a nod, that's good. Right, I'm going to click on this guy, and then I thought it would auto load, but never mind. I'll click on it a second time. It's loading up. What I've done here is put together, it's not a comprehensive, it doesn't have every formula and thing in the world. That would be even more horrendous. But it does have most of the formulas that you're likely to deal with. I'll make this a bit bigger. Oh, there's a good place, for instance. Triple integrals. This stuff here is very generic, so I won't worry about it. The key part is that, right? Center of mass on 2D, center of mass in 3D. Remember Jacobians? Basically, two-dimensional versions of U-subs. Do you know, we never did any just because they take forever in a day, but you know you can do three-dimensional Jacobians. That would just be the determinant of a three-dimensional. So you'd have an extra row called dx by dz, or dx by dw, I should say, and the last row would be dz du, dz dv, dz dw, and you'd get some ridiculously ugly thing. And that's the generic version of it. Just zooming through these guys, there's tons of them. I probably should change that one.
Solving a 3x3 matrix isn't too bad.
Not really, it's like a determinant of it. It's just big. It's just big.
Yeah.
It wasn't, the reason it was dropped or not used wasn't a difficulty thing, it was just a time consuming thing. Because the things just grow into a big monster, unless most of the bits are 0, in which case it's kind of trivial. That's the textbook version of, you know, little f of b take away little f of a. Right in here, that. This is a little bit more the way we write it, PQs and Rs. Little guy at the end. That's how we would do the fundamental theorem, right? Delta F is actually big F. There's Green's theorem. You can use it either direction. Actually, all of these formulas can be used in either direction, although I think they seem to like this way going that way more than the other. So they like this guy. To find this fella, which is the flux, you use that. To find this fella, you use that, so on. Anyway, it's just a resource to help you out. So on the day of the final, your final exam will have a different format than your typical WebAssign test. I think everybody's heard this at least once, but who knows who may have been missing. So I don't want it to suddenly be what the heck is going on here. And there will be a PDF that will appear at 1 p.m. just like WebAssign. So I'll have it in Canvas. I'll just not publish it, and then when the clock strikes 1, I'll go and I'll click on it, and it'll become visible. And it'll be a PDF, and it'll consist of 10 multiple choice. Okay, so you've got 10 questions. It's either A, B, C, D, or whatever, and 10 question section 2. So if you want to get a feel for it, it's 10 and 10, right? So far, so good. Now, your final is going to be out of 300 points. And the 10 multiple choice are going to be worth 10 points each. So be really careful about those. And your 10 section 2s are going to be worth 20 points each. So that will add up to 300. Now, if you don't know the answer to a multiple choice, will you please pick C or whatever your favorite letter of the alphabet is? Because you might get lucky. And don't pick C because I just said C. I had to pick a letter of the alphabet. And I've been told by people in the military that if you want to pass an IQ in the army, just pick C and you'll get enough to pass. This may be an untrue story, but I was told that.
When in doubt, Charlie out.
Is that actually a true story? That if you don't know, you just say C? It could be true.
There were lots of things for the multiple choice things. You sit there and look at your watch and go, okay, what quarter is the second hand in? That's the answer I'm going to go with. Then they said we couldn't use watches anymore. There was the 4-finger test. Slap your fingers on the desk and whichever one hurts the worst. Okay, use this one. But for the majority of the military, for multiple choice exams, they said, when in doubt, Charlie out.
Is that just a way to stop you spending 10 minutes guessing? Just get it over with and move on?
Potentially, but for the military, a lot of their, especially in the Navy, a lot of the exams had a near even breakup of A, B, C, and D. So out of a 200-point exam, you knew that you would have 50, roughly 50 of each. So if you sat there and saw the string of like, oh, I had 8 out of 10 of these were A's, and I had to guess on 3 of them, they're probably wrong.
Ah, so you would leave 4 questions you didn't know, and then you'd look at the A, B, C, D distribution and try to balance it out. Is that the strategy you're saying?
When I was younger and didn't know my job, yeah. And then as I got more and more senior, the advancement exams, a lot of times the questions were recycled. It was nearly the same for a lot of them. And, you know, you got like 4 hours to take this exam, and it had gotten down to the point where I was taking it in 30 minutes or less, and I'd get yelled at. You're not taking it serious.
Okay. I
did
guess
quite
it's
well on it.
it's the government bureaucracy of there's a box that's now been ticked, so we're all happy. We've gave them their test, they've passed the test, tick the box. Let's get back to work. Yeah. Okay, well, that's just a resource. I think everybody here has hopefully looked round. Let's get these guys sorted out. Has looked round this fella here. But if you scroll down later, you'll find that I have all the other chapters and PowerPoint and who knows what else to help you out. So you shouldn't really be missing anything. What will be different, so I'll tell you now, and I'm sure I haven't mentioned this yet, WebAssign will get locked out. The questions I'm going to be choosing will be very similar to those and ones you've done in your homework. So I don't want you to just say, oh yeah, that's section 16.3, go and look at your homework, see the answer to 16.3, and you've pretty much got the question done without really doing anything, right? So it will be locked out, so you won't see it. And the questions won't be quite the same. I will put in enough of a tweak to them just to make it that even if you did print out all the homework to all the WebAssigns, it still wouldn't be the answer you'd be looking for. You'd still need to know the method. And that's to be fair, because it has to be a good final has to be a reflection of what you know, not what you can find out by other means. And so we're making what you know the focus here. So I'm not trying to trick you. I'm just telling you up front how it's going to be so you don't get too many shocks. So it's, oh, now if I zoom back here, here's something that might cheer you up or depress you. Since there's only 10 section 2 questions, there's about 22 chapters. You know that half the chapters will not have a section 2 question in them. Section 2 is the long questions, right, where there's lots of work in. So you might be really, really good at doing double integrals in polar coordinates and never see one. And you're not very good at doing triple integrals in cylindrical, and that ends up being the bloody question you get. And that is called Murphy's Law, isn't it? So if you only study for half the stuff, I bet you it's the other half that I give you in the final. So you don't know what's going to be in the final. I haven't picked the questions yet either, although I have a bank to pick from. So even I don't know. Anything else? Any other questions? And then we'll start just picking topics or whatever you want to do. It's really open-ended today. You all pretty know everything you need to know? Oh, Canvas will be open. So see that formula sheet I showed you? That will be available, right? Any of the videos and any of the PDFs that are in Canvas are available. If you're allowed to use any physical written down stuff. So if you forget what the integral of secant squared is, you can certainly go looking for it online. That's okay. Right? There's none going to kill you there. Just curiosity. What is the integral of secant squared? Correct. Tangent. That's what James was mouthing, I think. Yeah. Okay, I'm ready to start. Get questions. What do you want?
Yeah. Could we do an example of a double integral y square root x plus y plus 1?
Okay, let me get a set up here. A double integral of
Y square root y plus x plus 1. And then dy dx or dx dy, whatever
Okay.
order is the best.
Do you want numbers here or do you want variables here?
Numbers.
Okay, so y can go from 1 to 2 and x can go from 0 to 1, and hopefully there's no weird stuff going on. Right. So I'm basically going to have to do this guy. So I would write him.
Could you do a y from 0 to 2? I think that's where my problem's coming from, I think.
The 0? Okay,
Yeah.
from 0 to 2. So I'm going to look at just this fella, right? Well, you know, that the x's happen after you've done this answer. So we'll focus on this. So what I'm looking at here is essentially y times this guy, right? Now, if you have a problem with letters of the alphabet, you might want to think of turning the x into 42. Just imagine it was a number, even if you don't physically write it. So what that is telling me here is that if I wanted to integrate this, I would have to do a u sub. Agreed? Now, what would the u sub look like? Well, if I did my u sub, I would get 1. And so du would become dy. And this fella would become y, u to the half. And the dy bit would become a du bit. And you might say, well, you haven't really made my life any easier because now I have a y and a u to the half instead of, you know, that guy. Well, not too bad. If you take this fella, you get that. Which means this can now be u, take away 42, take away 1, u to the half. If I distribute them, I get that. And then I can just do power rules. Two-thirds, what's two-thirds? Two-thirds is times it by 2, divide by 3. 3 actually works for that guy, but let's pretend it didn't. And then all of these guys get returned back into that. So what does that look like if we do it this way now? I'm doing a u sub. I'm going to differentiate. Technically, I'm differentiating with respect to y. So I'm going to get 1. The crossover is going to look like that. So I am going to do essentially a u sub. So it's going to be the integral of y, u to the half, du. Now, if you rearrange this fella up here, won't y be u take away x take away 1? Great. Y equals u take away x take away 1. So this becomes u take away x take away 1, u to the half du, which becomes 3 halves, that guy, that guy. Power rule. This fella, power rule. Oops. 2/3. Yeah, do that again. 2/3. 2/3. Then convert all the u's into y plus x plus 1. So next there. And now I can plug in y equals 0 and y equals 2. Good grief, what would that look like? 2/5. If you plug y equals 0, you get that guy. If you plug y equals 0, you get that guy. And if you plug in y equals 0, you get that guy, which you will now integrate from 0 to 1 dx. Now, although that is really ugly looking, would you agree that that is just basically some more power rules? And off you go. So I guess the trick to doing this was to realize that it had to use a technique from Calc 2 called substitution.
Awesome, thank you.
Not as clean as you think. You would have thought that might have been a kind of one line deal. It's about 6, 7 lines to do it. Do we have a topic? Another question?
Do you want to say hi, Professor?
Well, that is a good question. Yes, I want you to say hi.
Excuse me, where are we going over right now?
Well, that particular question was, I was asked to find a technique for finding this integral. So this would be a double integral. What would that, did this particular question come from some homework issue?
Yeah, it came from 16.7, question number 4. I
Okay.
think. Yeah.
So that one's from 16.7.4. So it must have been a byproduct of calculating a surface integral.
Yeah, I just ran into issues integrating right there.
If you look at integration techniques that you use in Calc 2, all of them apply in Calc 4. And the difference is that you won't have one variable. Very often you'll have 2 or 3 variables. But you've got to remember at any given point in time, all the other letters are treated as if they're numbers. So you can do U subs. I guess, I don't think we've ever seen one, but you could probably get an integration by parts. I mean, I get that off the top of my head. Can you imagine just a normal double integral if there is such a thing? That's not a very interesting one. But if I was going to do, say, that one, for instance, I could do it 2 different ways. Couldn't I just FOIL the heck out of that and get a very big, ugly polynomial? And that would work. I could also do a U sub. And if you work through it, it's slightly, but only slightly easier. So let's see if I can find an integration by parts. There's one. When you have to do an integration by parts on this fellow. Well, some of you do the UDV method, integration by parts. Others, if you got me, do the F and G method. If you do the F and the G method, you'd make this F and you'd make this G. or you'd call it UNDV. If you do the method that I use, it would be that guy. So you would get, leave that a guy, integrate that, take away, differentiate that, which is 1, integrate that. And then that would get you negative y cosine of x add y. Integrate that, you get a sine, so take away the sine of x add y. And so this piece here would be that guy. So you can do u subs, you can do integration by parts. Most of the time, from what my impression is, isn't most of the time just various power rules. So, you know, it's x cubed y squared, and you're doing mostly power rules. Okay, another question or topic?
Could we do a Lagrange multiplier problem?
Sure. Give me a few seconds. I am not going to make one of those up, because if I did, it wouldn't work. Oh, Leah, the little guy's in. Hi.
Good job.
Jason,
Okay.
Jason, you want to say hi? Hi.
Hi, Jason. Jason, how old are you?
Can you show me your cue?
So I'm going to say
Can you show me your fast card? Fast card? Here, hold it
suitcase. Say it fast.
up. Fast card.
Fast
Okay, he's still on cars. I gotcha. Hey, Jason, are you too?
Moonlight. Okay, Claire, you got
What's
to
he
join
say-
us.
What's he saying?
Mommy. He's just mommy's mommy's
You're going to
computer.
say the words fast, okay? Okay.
I'm
Sorry,
still
my
loading
daughter's
this up.
in her meat next to me, so it's pretty loud. All right, say bye-bye, Grayson.
Bye, Grayson.
Bye-bye. Is he fascinated with everybody in the class?
Yeah, he likes the lights. They do.
Okay, gotcha.
And stand.
Let's see. I need to go back here. Gardening space and things that aren't nice. Okay. Should have been better prepared. Okay, Lagrange multipliers, found one. Let's put it on view. Okay. First things first, want to check that right, you should be looking at the guy, so let's pick somebody who's got all the solutions here, of course, but I just need an answer. Okay, so this one, 7 will do. So I'm doing a classic polynomial, x squared plus y squared, add 8x, take away 8y, and they do an x squared plus y squared less than or equal to 49. And the way that they set down the solution is not the way I would do it. So, I mean, it would work, but it wouldn't be the way I would do it. Let's set up the puzzle. Okay, so at least I know I've got a question that's going to work, right? This here is your restriction, right? This guy here. So when we look at this this particular guy, isn't this going to be g of x, y, and it's going to be basically the x squared plus y squared. That's the function that is our constraint function. In this case, it's less than or equal to 49, which basically means we're looking for all the points inside a circle of radius 7. And delta F, oops, should be lambda delta G. That's the setup for Lagrange multiplier. The one I'm doing right now is a 2-dimensional, but can't you increase that to 3 or 4 or whatever you like? So what do we have here is that the partial derivative with respect to x, so in this case, okay, let's put in another. I'm just writing this down again so it's neat. Partial derivative of x, partial derivative of y is lambda, partial derivative of x, partial derivative of y. This fella here is 2x plus 8. This fella here is 2y take away 8. This guy here is 2x. This guy here is 2y. And then match first with first. So 2x add 8 is 2 lambda x. 2y take away 8 is 2 lambda y. And remember to put your restriction in. And sometimes it's equal to, sometimes it's less than or equal to. It could even be greater than or equal to. We don't care what it is, it's just its restriction. And why is that important? Well, we use any possible solutions. We use this equation, which I'm going to call number 3, to check if it's a viable one. So if I do a solution and it says x is 2 and y is 7, and I plug it in here, I know it doesn't satisfy the third condition, so it essentially gets kicked out. Does anybody know the standard next step? I always do one particular thing, and it ends up being, well, we'll see what it is. What's the next step?
Do you check if lambda is 0?
Right. Now, 9 times out of 10, the answer will come back, no. Lambda cannot be 0. If it was 0, it doesn't work, right? But if I don't check it, it will work, right? So let's check it out. If lambda was 0, wouldn't equation 1 be 2x plus 8 equals 0? And that would make x equals -4. So that's what equation 1 tells me. Equation 2 tells me that 2y take away 8 should also be 0, which tells me that y should be 4, which is what the second equation tells me. But is -4 squared plus 4 squared, is that less than or equal to 49? Well, I am glad I checked, because the answer is yes. So one of our solutions is x is -4, y is 4. But that's not all the solutions that might happen. That might end up being all there is, but it's not always the case that that's true. So return back here, and then you do a, oh, for want of a better word, a division trick. Can you remember how the division trick works? You divide some things. Can you remember what you divide?
The first 2 equations.
Now, if you take equation 1 and you divide the left-hand sides, you get that. And if you take equation 1 and divide the right-hand sides with equation 2, you get that. The trick of why the divide works, doesn't the divide get rid of the lambda? So what I'm going to have is 2x plus 8 2y take away 8, and that is x over y. And now I will cross multiply. And I will distribute. And I will subtract 2x from both sides. And I will divide both sides by 8. And I have just discovered that as long as y is equal to negative x, that may be a solution. But I have got to find who that solution is. Well, if you go to equation 3 and we look at just the boundary, it's that guy. And if y is equal to x, it's that guy. And that's x squared, so you get 2x squared gets you that, which means x squared gets you that, which means x gets you what? The square root of this guy, which is plus or minus 7 over root 2. You okay with me just doing a quick square root of top and bottom? And if x is equal to the positive answer, won't y be the negative of that? And if x is the negative of that, won't y be the positive? So I have that solution, I have that solution, and we had that negative 4, 4 solution. Now, very often in Lagrange multipliers, aren't you being asked to find max and or minimum value? I have 3 places where the optimum value works. This ugly square root thing, this ugly square root thing, and this guy. How do I find out which one of these is the absolute max or the absolute min?
You plug them into the original equation.
And the original equation is this ugly mess, right? So I don't want to do it because it takes too long. But for example, can you imagine I did the negative 4, 4 version and I got 17. And then I done the 7 over root 2 minus 7 over root 2 and I get 20, you know, or whatever. Wouldn't the biggest answer be the absolute maximum value that that function has? And that would be the point that it happened. And the smallest one would be the absolute minimum value of that function. And this is the point or points where it could happen, right?
There's some people talking in the chat.
Yes?
For the multiple choice portion of our exam, should we show work or just mark which answer?
There's a short answer to it, but let me qualify it. It's either right or wrong. That's the short answer. Show me working won't help.
Oh, okay. I
But
think
you
they were
should
asking
do-
about extra,
yeah.
or not extra credit, partial credit is what they were asking.
Not in multiple choice, nope. In multiple choice, you are just going to have to be ultra careful and make sure you pick the right answer. That has a benefit that you don't need to do 12 lines of working. It has a disadvantage that if you get it wrong, you get it wrong. But that's the rules for multiple choice, right or wrong. So cut as many corners as you feel comfortable with in the multiple choice. Guess if you're really stuck. That's the good part. The bad part is that you know, you could do most of it right, but screw up at the end. So just be extra careful. It's my advice. Well, it's time. God, that didn't feel like we had a lot done. I'm going to be up and about all next week. since your final isn't till Friday, there is a little window of time. So if you're really stuck, contact me. We can do a Zoom thing. I think a lot of these puzzles are very easy to do on paper, would be horrendous to try and do through an email. I'm not even sure it would make sense if I tried to do some of those questions through email. So anything you get stuck with, talk to me about it, shoot me an email. I think that is us. Is there any last question?
This is sometimes what exams feel like. You feel like you haven't done anything, look back and realize you're almost out of time.
Yeah, pretty much. You're so focused on doing the exam and you haven't done anything. And then the bell goes, right? Or whatever it would be. Hopefully the 3 hours will cushion that blow a little bit, right? So you won't feel like you just have to get it done. Hopefully you'll say, yeah, I got enough, leeway there to be a little bit more careful. Strategies. Do questions not necessarily in the order that they are, but in the order that you're good at. So if you're really good at triple integrals and it happens, you may want to do that as one of your first questions. If you really don't like the divergence theorem, because it never seems to work right when you do it, you may want to keep that to your last question. In multiple choice, if you know what you're doing, the multiple choice question should only take less than 5 minutes. They are not particularly, what's the word I'm looking for? Long or difficult. A multiple choice should be a kind of 5 minute would be extreme. So if you think you know how to do it, but it's going to involve 2 pieces of pages of paper, you're doing it wrong. So don't even try it that way, right? A lot of multiple choices, just off the top of my head, if the divergence of f equals 0, which of the following would be the value for the curl? 0, 42, depends on the function, none of these answers. Right, things like that. So do you see in that question, there isn't any math to do, it's I just know stuff. Does anybody know what's special about a conservative field and a closed loop?
Doesn't a conservative field not so much depend on the path?
Correct. So can you imagine I might just ask you a multiple choice question connected in that way? So can you see that not all multiple choice questions are find this double integral or find this surface area, whatever it might be. They could simply just be questions to do with the bigger picture, right?
Oh, and I had one last question before I go. So is there going to be a section that's multiple choice and then also a section you have to write out?
Yes.
Okay.
And when you write your answers down, you will just say question 1A, question 2C, question 3D, right? That's the multiple choice part. That's all I'll say. And then section 2, you'll show me every bit of working you can think of, right? So for that last 10 questions, you're going to really give me every line that you can so you can get every piece of partial credit that's out there for you. But for the multiple choice, it's right or wrong, so you go for it. Don't spend 2 hours doing the multiple choice. It's a bad usage of your time. Do James thing, just pick C for all of them, and you're probably going to get 3 right? That's 30 points without even doing anything.
And then at the end, I think I remember your other exams, finals usually have like an extra, like
yes,
it's harder than
same
usual.
Same thing is true. You get 30 minutes to get it uploaded into Canvas once it's over.
No, I meant other exams from the past I've taken from you. I think normally there's like a extra, like harder one at the end.
Oh, a bonus question?
Mm-hmm.
No, not this time. Sorry, guys.
Okay.
Yeah, that would be something I would certainly do in the personal situation, but not this one. Been a lot of good questions here. If you come across with some other ones, because you thought, oh, I should have asked them, shoot me an email. I'll try and answer it for you. If that's it, I'm bye-bying. I'll see you when I see you.
Real
real quick, considering it's a 3-hour exam, is it starting at the 10 o'clock start time or is it earlier?
It's starting at 9 o'clock.
It's at 9. Okay, thanks.
So it's going to.
Everything says it starts at 10.
Is it?
It goes till
sorry.
1.
I take that back. You're right. I was looking at the wrong. I was looking at tests starting at 9. Yes. 10 o'clock till 1.
Okay, thanks.
It might be a good idea to make an announcement just so that people see that, so they don't have to email you and ask if they forget.
I can do that. If you also look, it's written down in your syllabus, and it's also written down in your class schedule. So it's in 2 other locations as well. But it's not hard for me to, I will probably shoot out an email because some of you missed today, so there's certain things you don't know. Hopefully they'll watch this video, but you never know, they may not.
So the test Monday is still at 10 o'clock, right?
10 till 9 till 11, is it? When's our test? Our test is not
an hour long.
No, our test is only an hour. We changed it to an hour because of scheduling. So our test is going to have 4 questions in it, 1 from each of the 4 sections, as you'd expect. And I get you at 9, don't I? No, I get you at 10, so the test will be at 10, won't it? Yeah.
All right, cool.
Okay, bye-bye, guys.
Is that your dog in the background?
Yes, it is.
Well, bye. See you whenever I see you next.
I will see you Monday or on Friday.